Okay, so open-minded octopuses, we are a data science team. And that means we had like a little different approach to these other teams that have gone so far. So we have one big website as opposed to a presentation. And I think we're going to kick it off with our trailer over here. And unfortunately, screen share doesn't work with full screen for clip clamp. So you guys are going to have to deal with this looking a little bad.
Are you curious about your earning potential? Wondering what you could be making in your field? Look no further than SalaryCents, the sensible solution to unlock your salary possibilities. With SalaryCents, you have the power to explore your worth in the job market. Our intuitive platform combines your age, years of experience, and field of work to provide personalized salary predictions, so you'll never leave money on the table again. Simply visit our website, input your details, and voila! A comprehensive and sensible salary estimate tailored specifically to you. But SalaryCents is more than just numbers. It's the sensible guidance you need. We advocate for fair compensation and pay transparency, helping you make informed decisions about your future. It's like having your very own salary superhero. So, why settle for guessing when you can get the facts? SalaryCents. Your sensible key to unlocking your salary potential.
Yes, so that's our trailer. It's accessible through our website, so students can access it anytime. William, are you ready to kick us off?
Yep, I am. So we're the open-minded octopuses, and we're here with our innovative product, SalaryCents. So have you ever wondered how much you would make at a new job? Are you worried that you're being underpaid? You might try and look it up on Google, but then you get a wild range of 35,000 all the way up to 120,000. No need to worry. With SalaryCents, where we use machine learning models to predict your future salary using age, gender, education, job experience, and field. Invest in SalaryCents for a sensible future.
We found our salary data set to work with on Kaggle, but we had to clean it ourselves if we wanted to use it to successfully perform supervised machine learning. You're able to view our final raw file hosted on GitHub. Our data was collected from an unnamed technology company in the United States. Our data won't reflect the salary information of every individual, but our project can be easily expanded upon with more diverse data representing more fields and countries. In the Kaggle data, there was 191 individual jobs represented, many having only one person, so we grouped them into 10 bags now called fields. For example, software development was a field we created to group together job titles such as junior software engineer, full stack developer, and network engineer. There was also an other category for gender in the Kaggle dataset with only 14 data points. This isn't enough data to draw accurate conclusions, so we dropped it for now. We want to predict annual salary, so salary became our target variable. This left us with those 5 features for prediction: age, years of experience, gender, education level, and field.
Next, we show our graphs. Here is job fields and a distribution pie chart showing that software development is by far the largest field that we had, but sales and marketing and research analysis was close. Going on, we have a violin chart showing the salary distribution of each of our fields, showing that each of them are pretty dispersed between all pay ranges, except for customer service and support and creative and design, showing not more than 75,000 for most jobs. Next, we have salary distribution by education level, also showing a pretty even split between high and low wages, other than high schoolers who are high school education, which is not more than 75 most of the time. Next, we have our salary by gender, showing a pretty even distribution between the 150 and 200,000 mark. It shows a slight preference for males. And finally, we have a scatter plot, which is salary by years of experience, with the colors being education level, showing that people with high school degrees with not many years of work are usually not paid as much as people with a lot of years of experience and higher degrees.
R squared measures how well a regression model fits the data, ranging from 0 to 1. A good score, 0.9 or higher, means the model explains a lot of the target's variance, indicating a strong fit to the data. On the other hand, MAE, or mean absolute error, calculates the average prediction error in the same units as the target variable. Lower MAE indicates better model accuracy as it represents the average absolute difference between the predicted values and the actual values in the data. KNN is a popular machine learning algorithm for regression and classification tasks. It finds k closest neighbors to a data point in an n-dimensional feature space, where each dimension corresponds to a feature in the data. For regression tasks such as predicting salary, KNN predicts the target value by taking the weighted average of the k neighbor values. The model's effectiveness in explaining variance and making accurate predictions is evident from the high R-squared value of 0.934 and low MAE of 6,494.
Decision trees is a model that generates a tree and then narrows down action using if-then decision rules. Each node of the decision tree represents an if-then test on an attribute, and each branch represents the outcome of that test. The R-squared for decision trees was 0.94, which is very good, and the MAE is 5,278, meaning the prediction was on average off by $5,000. Bagging is an ensemble method that controls for variance by randomly selecting subsections of data to train with, which are then combined to form an output. Bagging using KNN, the R-squared was 0.935, and the MAE tells us that on average, the prediction was off by around 6,500. Whereas bagging with decision trees, the R-squared was 0.947, which is an improvement from KNN, and the MAE is 5,377, which is also less than KNN.
Now that we see that how it may have worked, let's actually use it. So say that we have a 22-year-old with 2 years of experience, male, and with a bachelor's degree and going into research and analysis. Let's see how much they would make.
I think our site froze. Loading.
Unfortunate. This is the worst.
Wait a second. It should be working. Oh God. Okay, the way our Flash site works is sometimes if you don't like reload the page enough times, it will stop. So we have to rerun it. Sorry, guys. Let's resend this. We can navigate with our toggle and we can redo this. Sorry. So it gives us an estimation.
All right, so it gave us 107,000 bucks. So someone from chat suggested 30-year-old male, bachelor's, 5 years of experience, and in software engineer. So your predicted salary is 98,000. All right, let's move on.
Model analysis and conclusion. Our best performing model was our bagging regressor that used decision trees. Although alone, the decision tree model already performed well, using the bagging regressor helped slightly reduce the variance as it included randomness and improved our R-squared score. Here's our violin plot that compares real versus predicted values in the salary distribution. Other features, years of experience and education level had the biggest effect on salary. Age and years of experience were highly correlated, but years of experience was a better predictor for salary. Field was complicated as it sometimes had big roles in predicting salaries, but there was a lot of variance in fields. Field was also correlated with education level, as some fields required a certain education to enter. Gender was our least predictive feature. Our analysis showed that men on average earn more, and men were overrepresented at salaries higher than 160K. However, gender is also correlated with field. Focused analysis on gender salary could lead to more conclusions. Overall, this project was a great way for us to learn more about machine learning process and full stack development, collecting, cleaning, and analyzing data, learning how to train different models, and deploying our project to a website was fun and interesting. When it comes to limitations of SalaryCents, the first main limitation is the accuracy of our salary prediction. Our mean absolute error was consistently around 5,000. This could be a problem for users who want more accurate estimation. Secondly, our data itself provides limitations that only covers specific fields and only focuses on a region in the US. It will be further explained through our future expansion.
Our salary prediction is only based on 5 features. Adding more features would be a great way to improve our product's accuracy. Some future expansions to our feature could be information like location and region. Different regions of the United States have different job markets and different expected salaries. Salary also differs between urban and rural areas. Adding data from different countries would also improve our product, making it available for international users. Furthermore, another expansion that is possible is the future could be the inclusion of current economic trends and inflation. In addition to adding more features, we could add more fields that are not currently accounted for in our model. Job fields not represented in technology companies such as construction, medicine, education, etc., are not a part of our current model. Adding more job fields may be the best way to start expanding the reach of SalaryCents.
I'm Ariel, a freshman rising to be a sophomore, and I like cramming coding and mathematics.
I'm Ayana, and I hope to expand my knowledge on machine learning and its practical applications.
I'm William, and I've always had a curiosity for how AI works, and this camp really helped to answer that question. In addition to learning, though, I've found a great community.
My name's Isaiah, and I'm building this to learn about machine learning and use my basic understanding of Python to like see what work in the field looks like.
My name is Robert, and I'm interested in machine learning because it sounded interesting, and I took computer science at my school last year, taking a real interest in the computer science field. I'm excited to use what I learned here and take it back to school and expand on it. I'm going to be a sophomore next year in high school, and I'm glad I took part of this AI camp.
Hi, I'm Timothy. I'm going to be a sophomore next year. Seeing how big a thing AI has become, I was interested in understanding what it is and how it's evolved. After spending more time working with machine learning, I've learned a lot of skills that I'll continue to explore.
This has been this is Open-Minded Octopuses with SalaryCents.
Great job, guys. I can send a link that should work to the Replit, and because it's so quick, we can also try like one of the suggestions people left in the chat for salary. 5-year-old with 15 years of experience. Six-year-old with 15 years of experience. It looks like he's gonna be making kind of a lot.
If you're breaking the laws of physics.